Hello everyone. So I'm gonna actually talk about the problem that was challenging for most people during the test I gave. So this question was the problem that most people actually miss. So which is why I like to make a video about it. Okay. So the question is like a triangle. It says using the Pythagorean and the quadratic equation to find the side lengths of this right triangle. So we are told the shoulder leg is 5 meters like shorter than the longer leg, and the hypotenuse is 5 meters longer than the longer leg. Okay, based on this, we want to find all three sides. So let's get started with maybe drawing a picture. So I'll say, let's say this is the right triangle, right? We are told the shorter leg is 5 meters shorter than the longer one. So which means the longer one should be five more. So whatever this, so you are going to add 5 to this guy to get the longer leg. And the hypotenuse will be 5 meters longer than the longer leg, which means if you add 5 to this number, you do get x plus 5, which is x plus 10. Okay, so this is what we are given. Based on this, what we like to find those values. But we don't know any numbers, concrete numbers, but we do have all three somehow relation. So we may just use the Pythagorean. So the Pythagorean was telling us when you square the legs, that is gonna be square sum is just the square of the hypotenuse. So in this case, my leg is x, one leg, and I square that. The other leg is x plus 5. Okay, so that is gonna be square and equals c squared. C is my hypotenuse, which is x plus 10. Okay, so then we have this equation. Now we like to solve this equation. After this is just algebraic manipulation, maybe using the quadratic formula from algebra 1. So, but if you can expand this immediately, go ahead and do that. But if you cannot really see it, you need to write this as a product of x plus 5. Let me just write what I'm saying. So x plus 5 squared is just x plus 5 times x plus 5. Because the square means you multiply whatever have base just by itself 2 times, like that. And then you have x plus 10 times x plus 10. Okay, so far so good. I guess we just need to expand those two parentheses. So you multiply x by, like, let me just, x by x. So the x times x would be x squared. And then if you multiply x by 5, you get 5x. And then you multiply 5 by x will be 5x. And then 5 by 5, which will be 25. And that's the left side. And then you multiply the same thing. So x by x will be x squared. X by 10 will be 10x. And then 10 by x will be another 10x. And then 10 by 10 will be 100. Okay, so let's simplify, but I see I can subtract x squared from both sides to make it a bit less complicated. So do I have x squared, and then I have 5x and then 5x, so it can be combined, which is going to be 10x. And then there's a 25 after, which is equal to, on the right side, we have 10x plus 10x. Maybe we can combine those as well, which is just 20x, right? So 10x plus 10x, and then there's 100 here. So we have a quadratic equation. You know, whenever you have quadratic, it's better to pull everything one side. So I can subtract 20x from both sides. So if I subtract 20x from both of these, so you should get cancel these guys. But at the same time, I don't like this either. So I'm going to subtract 100. So I'm going to subtract 100 as well. So these guys will cancel. So you will get x squared. 10 minus 20 is just minus 10x. And 25 minus 100 will be 75, but it's going to be minus. So again, at this point, if you don't really remember the quadratic formula, which is maybe a bit challenging, so you can probably try factoring, or you can just go ahead and plug the values if you feel you are going to be lucky. But let me try using factoring first, and then maybe we can use the quadratic formula as well. The factoring is like something like this. Let me show in a different color. So you have x squared minus 10x minus 75 equals 0. So your goal is to find two factors. When you multiply, you should be getting those three terms. Usually we look at this number right here. We like to find two divisor of 75. I mean, negative 75. And then when you add those to divisor, you should be getting this number, negative 10, which looks like 15 and 5, but I like to get negative 15 to get negative 10. So which is why I will go with x minus 15 and x plus 5. So again, if you multiply x by x, you get this. To confirm, x times 5 will be 5x, which is a plus 5x, and minus 15 times x will be minus 15. When you combine, you get this term, and then when you multiply negative 15 by positive 15, you get minus 75, which looks good. So the product of two things is 0, which means this guy should be 0, or this guy should be 0. So the x minus 15 is 0, meaning x is 15. Okay, and x plus 5 is 0, meaning x is negative 5. But negative number cannot be a side because that's the triangle side, so we cannot accept this one, so that it has to be 15, which means this is 15. And then that would be 5 more, will be 20, and then 10 more of 15 will be 25, then we are done. So this is by using factoring. So if you like to use the quadratic formula, you actually can do that as well. But let me do this just for the sake of reminding people. So if you don't remember, so let me clean this part. Okay, so the quadratic formula is like this. So you have ax squared plus bx plus c. This is called quadratic formula. And then a is this number, the number in front of the square term, and b is the number in front of the x term, and c is the constant. In our case, the number right here is 1. We don't write it, so which means our a is 1. But before I write ABCs, let me write the formula itself. The formula is minus b plus or minus b squared minus 4ac over 2 times a. So let's use our quadratic formula. So the a is just the number right here, which is 1. And then b is the coefficient of the x term, which is negative 10. And c is negative 75. Okay, so the formula says take the negative version of b. So b is negative 10. So you take the negative of that number plus or minus, and then b squared, which is going to be negative 10 to the second power minus 4 times a. A is 1, and then c is negative 75. Okay, so maybe it's better to write in parentheses. And that's under square root. All this divided by 2a. Okay, so then, this is going to be 100 because negative 10 times negative 10 is 100. And then you got three numbers to multiply right here, 4, 1, and 75. If you multiply 75 by 2, you get 150. If you double again, you got 300. Since we have minus and minus multiply, that will be plus. That will be 300 right here, but there is a 100 right here. So if you add them, that is 400. And then that would be just 10. 10 plus or minus a square root of 400 over 2. Okay, so from there, so the square root of 400, if you remember, this is 20 squared. So then the x1 would be just the 10 plus 20 over 2. Again, 20 is just the square root of this guy. So which is going to be 30 over 2, which is 15. If you remember, that was our answer anyway in our first approach, right? So we got that 15 right here. And that is done. If you like to find the second solution, if you want to do that. So that should be 10 minus 20 over 2, which is actually negative 5. And that was also right there. Again, this quadratic formula approach is something you can do if you cannot really factor it. But since that was much easier for me, I did that first. But there is also another possible way to do so. Okay, and if you know how to complete square, you may actually complete the square as well, which might be a bit better than the quadratic formula, but that's another way to do so. And the last resort, let's say you couldn't really factor, you couldn't use the quadratic formula, you couldn't like do the complete squared approach either, then as a last resort, you can plug numbers. You know, since in our case at least the number were integer, in this equation, you can just plug some values and see how that looks like. And maybe you might be lucky after some trial, but that would be your last resort. Okay, so I wouldn't really do that way unless I really need it. But one more thing I can try, maybe I can use my Pythagorean triple. If you are aware, something we call Pythagorean triple. This is actually a triple, so that might be useful in some cases. But since the title was telling us quadratic equation with the Pythagorean, I just use like quadratic formula, which is a bit longer, to be honest. But I think it should be good with the factoring. Okay. So anyway, so I hope that makes sense. Let me know if you have more questions, and I'll see you next time.